Hello, my name is Gaetan Pelletier with the Northern Hardwoods Research Institute. Today I want to talk to you about a concept that we started to elaborate about 4 years ago. It is the NHRI Precision Harvest Treatment Tool. But first I want to backtrack a little bit and talk about the context and the reason why we think a tool like this should be developed. Our hardwood forests are not quite managed fully to maximize value at this point, and this is not only a New Brunswick challenge, it is pretty common in eastern North America. The hardwood stands we are dealing with are highly variable. The silviculture is very complicated to implement. With hardwoods, we rely a lot on partial treatments that become part of a silviculture system. So not a lot of clear cutting in our hardwood stands. We don't mark trees in New Brunswick, so operators must have mechanisms to help them select the trees to harvest so that we meet the objectives of our silviculture treatments. And very often, because those hardwood stands are highly variable, there's a need to change or to adjust the prescription as we go on the fly. On the utilization side, bucking hardwood trees for value, trying to find an optimal bucking recipe is tough. Furthermore, our hardwood trees have a very complex art. The optimizations in place today in harvesters is not well suited for hardwood trees. Those processes, algorithms, measuring methods were really designed for softwoods where everything is based on taper and prediction of a minimum, the length at which we find a minimum top size. This is not the case for our hardwood trees. So this concept of a precision harvest treatment tool, what does it involve? First of all, we think we should be leveraging high density LiDAR technology and high density point clouds. We think the tool should be embedded within the Institute's technical silviculture planner to determine the right treatment to implement based on inventory inputs. We also want this tool to feed off all the work we've done to predict products within hardwood trees, and then look at proposing some optimal bucking solutions to try to maximize value within the value chain. And then we also think that because we don't mark trees and because we operate at night and the stands are very variable, there should be the development of aids, visual aids for operators so that they can conduct the right treatment. This tool will fit at the point where we have selected which blocks should be treated. The decision to treat a block is done outside of this tool. We want the tool eventually to process data right in the cab of the machine using the onboard computer. This might be challenging because of imperfect communication for data, and also there might be limitation just with the computing power of onboard computers. We also want the tool to be flexible as of which method is used to generate high density point clouds. They can come from LiDARs on UAVs, they could be multiple pass traditional airborne LiDAR, they could be terrestrial LiDAR derived, or the point clouds could be generated from a photogrammetric process. So a little bit about strategic framework and alignment at the Northern Hardwoods Research Institute. A while back, a few years ago, we developed a framework that would help us prevent just conducting one-off projects in isolation. We wanted to have a view of where we want to go so we can achieve our value proposition for the forest sector. Everything we do at the Institute must either increase volume available for sustainable harvesting or must improve the quality of our hardwood trees, or sometimes both. And to do that, we created this framework that starts with what we call the NHRI Hardwood and Mixed Wood Silviculture Toolbox. NHRI Hardwood and Mixed Wood Silviculture Toolbox. Within that, there is 13 tools or 13 modules that are in different stages of development. And the project we're talking about today is a specific module within that silviculture toolbox. It is called Module 10, the Precision Harvest Treatment Tool. And then within this initiative, we will develop several projects so that they can be managed efficiently. And one of them, we are very advanced in its planning with Université Laval. So the toolbox currently has 13 modules. The ones in green have been developed. They might need some improvements of advancements. What is in yellow? We have started building those modules, and in orange, these modules are yet to be developed. So Module 10 is the one we are interested at today, and it is linked with all or most of the other modules within this toolbox, and we will talk about this in a moment. So let's start talking specifically about this tool that we want to start developing. The tool really will work within a process that has about 6 steps at this point, and for each one of those steps or components, several projects will be tackled in order to get the development underway. For example, with Eric Labelle from Université Laval, we will be tackling the task of measuring hardwood trees and then proposing optimal bucketing solutions using and developing new algorithms in the onboard computers of the machines. Another project that will be discussed very shortly is a continuation of the work that Richard Fournier from Université de Sherbrooke has been doing with his doctoral student Bastien. So with them, we acquired the very high density point clouds using using LiDAR scanners on UAVs. We compare that with terrestrial LiDARs in the same area, and Bastien is developing tools for automatic extraction of tree metrics using those very dense point clouds. So the first component of our tool, or the first step in the process, consists of generating information at the area base, so the 20 meter by 20 meter pixel for the stand or the block that we are interested in. And much of that work comes from already developed tools at the Institute within this silviculture toolbox. We have a vigor mapping tool that uses satellite imagery, multispectral, to predict in this case 10 meter by 10 meter sentinel pixels, we're predicting the vigor of those microstands. Then we have our hardwood quality potential mapping tool. It is a tool to help us decide if it is worth investing extra energy and resources for a particular stand, in case it is not developing good quality hardwoods. The next element of that is our EFI generation tool. This will be a big standalone project. It is not yet started, but we want to get into the business of generating next generation enhanced forest inventories using enhanced forest inventories using other data as well as LiDAR data. The next step or component for our tool is the assignment of a prescription, an actual treatment for the block in question. We are currently building our tactical silviculture planner that uses existing high quality enhanced forest inventory data, and using the logic developed at the Institute assigns a treatment that is part of the silviculture regime. The logic that we're talking about was developed under our now mature silviculture prescription system, and the treatments are planned and implemented using a process developed in the last couple of years that we call our precision block planning process. The SPS is the flagship product of the Institute. So it is the silviculture logic that we developed so we can practice sustainable forest management for our mixed and hardwood stands. We came up with a new release this past winter. We now call it SPS version 2.0. A 5-step process that starts with input on the inventory of the stand and characteristics of trees, and eventually ends up recommending a single treatment to implement. Those treatments are very well documented. We make sure they are embedded in silviculture regimes and silviculture systems and subsystems, very clear objectives for the treatments, and we also built it so that it is immediately compatible with results-based forest management or outcome-based forest management. Ultimately, when a treatment is recommended and accepted, we produce standard work orders for implementation. So these are very, very important pieces of information where we propose a sequence for implementation, about the trail network to implement, what is the residual density target within the strips, what is the cut priority, what is the picking order, what trees to cut first. And then we also talk about other important factors to consider. So these are very specific instructions for the machine operators that ideally will take away the need to mark trees. This was inspired by FP Innovations and the Canadian Wood Fiber Center's 1-2-3 method developed a few years back. And it is in essence the critical piece operators need in order to do the right job. Finally, this tool will operate within our existing operational harvest planning process developed at the Institute in the last 2 years, and that is now being implemented for the second year in a row in industrial operations of northern New Brunswick. This is a very straightforward process that ensures candidate blocks that were picked from a strategic plan are really examined using the best information available, altered, improved, changed before they are passed on to the operational folks for implementation and harvest. First two steps or components under this tool really start from already existing modules at the Institute, or at least information that is available. The next and the last four components or steps in this new tool that we're developing have to be constructed from scratch and don't exist. So step number 3, or component number 3, is about implementing tree-by-tree solutions. So this requires high-density point clouds. It requires a new logic that applies to single trees in terms of proposing to the operator how to buck those trees. In the past, we've developed the capability of mapping valuable trees at risk of losing value and vigor. So what we learned from this exercise will be built in this new component, or new. But really, the exciting thing is the departure from today's standard 6 to 8 points per square meter airborne LiDAR scans that are implemented wall to wall in our province, but start to look at very high density point clouds. In the last 3 or 4 years, the Institute has been exploring that sphere, and we've actually covered some areas, some tracts of lands where we could generate point clouds in densities higher than 500 points per square meter. So this allows us to really look at single trees within a stand or a micro stand or an operational block. We can start to consider making tree-by-tree decisions. We've developed with the Université de Sherbrooke the capacity to extract single tree information in terms of geometry, but also in terms of allometric tree measurements, and going almost as far as product planning. The next part that is exciting about these high density point clouds is the capacity at this point to produce augmented reality or 3D based products, so that the operator live on the computer, on the onboard computer in his machine, could see in 3 dimensions, or a representation of 3D, the trees that are coming up ahead of the machine. We could develop algorithms that would recommend which trees to cut, and for those trees to cut, we hope to be able to recommend an optimal bucking solution based on the body of knowledge that we have developed so far at the Institute. So this technology to extract tree measurements or information from high density point clouds is already out there. The final 2 steps in the development of this tool are not very well elaborated at this point, but they are about using all the data in artificial intelligence, and how can we use that to optimize the value chain, improve decision algorithms, and do a complete 360 within the process flow. So there's much discussions to be had about these 2 last components, and we will be happy to get a team together to come up with the framework required to conduct these 2 last steps. So this wraps up my quick introduction to our proposed tool module, the precision harvest treatment tool.